I'm Joe. I'm the tech lead for Grafana SLO, which is a Grafana Cloud application, and I'm going to talk a little bit about how we built it on top of our prototype for the Grafana app platform. So I'm going to expand a little bit on what Stephanie and Ryan talked about. I'll walk you through what Grafana SLO is, sort of the functions of the app, and the architecture we use for that, the sort of operator architecture, and how we use features of the app platform to make that work. So Grafana SLO is installed in every Grafana Cloud stack, which means we've got thousands of installations across dozens of clusters all over the world. And we built it with a team of 3 engineers and a UX designer. The team has grown a bit since then, but that means the front end and the back end, 3 engineers and a UX designer. And that meant that we kind of needed some help to do a lot of underlying stuff, right, to make the team productive. And so I met with some people at Grafana who pitched me on this concept of the app platform that could really save my team time. I'll talk a little bit about the app. So SLO stands for Service Level Objectives. And service level objectives are this framework for how you can build a better software engineering culture at your company. And basically what it asks you to do is to measure what your customers care about, which might be the latency and success rate of a checkout process in an e-commerce app. It might be outputs from your meat-free manufacturing process, right? It might be the quality of the output you're producing, the quantity of the output you're producing. It might be whether your kid is keeping his room clean. And then it asks you to set a goal for that measurement, and which might be like checkouts succeed in less than 1 second, 99.95% of the time, right? It's really important that your customers can give you money. Then you're going to compute whether you're meeting that goal over time and get alerted when you're in danger of not meeting that goal. That helps you measure what's important, respond when what's important is broken, and not wake up at 3 a.m. because the disk is 95% full. Who cares? Who cares if my customers can give me money? So that's what the SLO framework helps you do. Now, there's a lot of little fiddly things involved in that. There's a great blog post from SoundCloud about sort of this framework. There's a whole book from Google about it, but how many people in your company are going to read that whole book? As you get better at using SLOs, you can use them for more than just measuring and alerting. Now you know how you've been doing over the last month, 2 months, 3 months, and you can start to make plans. You can adjust your team's behavior based on how well you're doing. You can say, I need to trade off feature work for reliability work because I'm cutting it really close in terms of my objectives I'm trying to meet. Or even, over the last month, we had a horrible outage caused by XYZ, and so we underperformed what we expected to do. So you can adjust your behavior based on your past measurements. So that's what our app does. It makes it easier for you to define what's important from your application based on your metrics. It handles the math of alerting, computing, whether you're meeting your objectives, and it provides a bunch of visualizations. So you don't need Grafana dashboard experts to make this happen. You don't need to be steeped in the math of computing whether I've met my SLO in the last minute, hour, 30 days. When should an alert take place based on those problems? So that takes some burden off your SRE team and lets you give it to the application developers who ought to be monitoring and responding to problems in their service. So we want to make it easier to make all of that smoother for people. Here's a view of one part of the app, which is part of the creation workflow, which is basically let's not write a huge expression in Explore or a big expression editor and then save it, or write it in some YAML file that we put as a rule in our Prometheus configuration. We guide you through selecting, right? In this case, no 500s, less than 500 milliseconds is the sort of definition here, right? You can see this in success metric on that thing. And then we guide you through setting up alerts. You go through a review of what things are going on. In this case, the SLO is a really loose 75% success rate. And then we generate dashboards and metric recording rules and alerting rules. We highlight if there are any current alerts. We tell you how you're doing over time. And we generate an overview dashboard for every SLO at your company so you can get a broad view. And we also provide drill-down capabilities into these SLOs. These are dimensioned. It's not just one measurement across your whole company. You can group them by your cluster that they're in. You could group it by all sorts of dimensions. At Grafana, we tend to group by cluster because we tend to have geographically isolated kind of failures or global kind of failures related to shipping a bug. So that's a really useful way that we use the tool to dig into where problems are happening. So, great. What's a dashboard? What's an alerting rule or recording rule? It's some config, right? Oh, just generate some JSON, post it into a file, put it somewhere that the Prometheus operator can pick up. This all sounds, fairly simple, but things break all the time, right? Metrics database could be down when you're trying to define an SLO. Do you want to stop everybody's work because of that? Dashboard APIs might fail. Things just happen, right? Somebody might restrict the folder you want to put the dashboard into, like the one person who's allowed to access it now. That might not actually be what you want to happen. So there's a lot of ways that simple things can fail, right? And so we want to do a lot of this work asynchronously in a way that can be retried and in a way that works reliably. Another reason we want to do these sort of things asynchronously is scale. When you have a few hundred SLOs, you want to Terraform apply every single one of them. If you're synchronously like, make me a dashboard, it takes 500 milliseconds, things get really slow. As code tools get really sad. So we like to decouple them and make them asynchronous. So a model that Stephanie and Ryan also talked about that works well in that case is this sort of, call it an operator model, call it a reconciler model, which is operators watch things and then they take actions. And their goal is to put the real world and the desire, and what's configured together, right? To bring the real world to match the configured state. The nice thing about this pattern is it decouples all of those API actions from all of the underlying work that might happen. And there's a lot of different kinds of underlying work that you could program. But in our case, it's to create these two dependent resources, alerting and recording configuration and a set of dashboards, right? It's not just a dashboard per SLO. It's this summary dashboard that needs to exist. And it also is a good way of not only responding to user input, but responding to code changes. If we change what a dashboard should look like, because the app has become more advanced, we have new features, we want to put that in things, we have new alerting rule configurations, all we have to do is ship a new version of the operator here. The operator spins up, it syncs and sees all of the current config, it sees that the real world is different from what the new features of the app are, and it makes those changes, right? So we don't have to, so it's relatively simple for us to ship new features and then have them reconciled as well. So, talk about what in the Grafana Cloud app platform, which is our prototype that we built that is now, we're starting to implement the things we learned in Grafana itself, what we use from that. So I'm going to start with the schemas and code generation stuff. I'm going to talk about the storage service itself and the APIs associated with that, validation that comes along with that, and what watching resources does for us. So schemas. Grafana's SDK provides an awesome, easy way to define a schema, which is in this nice data validation language called Q, capital C, capital U, capital E. What's nice about Q is it's super compact compared to a lot of other ways that schemas are defined. Except maybe protocol buffers, it's one of the more compact schema definition languages I've looked at. I want to highlight, you start with something simple like this, you get a bunch of stuff out. I want to highlight a couple things here, which is that I'm asking for code for the front end and a back end process. I have defined one version of my config object here, which is v1 alpha 1. In this spec, you can define multiple versions right in line in the same thing here, give them all names, and say which one should the storage service be using. This makes it nice because you get code gen for all of those versions, and that makes writing migration routines between them really easy, right? Actually have everything typed there, and so I'm not writing some kind of SQL update kind of thing that may or may not be typed, and all of those problems that we've all run into in the past. So this is a pretty compact definition. There's only two things in here. There's two optional fields. What alerting system should the SLO app use? And This is narrower than I thought. Sorry, we're missing a little bit here. But basically, what the recording rule policy should be, we have ways of saving our customers money when they don't need some of the data, or giving them all of the rules when they do. So these are restricted string enumerations, right? A learning system can only have those two values. After I run the code gen, I get this OpenAPI v3 version of that definition. It's a lot longer. I'm really happy. I don't have to type spec group versions name serve storage schema API vscript. You know, this is mostly a convenience factor to get from here to that. You can see it has some of the same things, right? It's an enum with data source and Grafana associated with it. You get some Go code out of that. I have some nice typed constants. These are optional fields because they're pointers. I get even types for the different fields. Again, it's just stuff that makes it harder for me to fat finger something. I have fat fingers. And we get some TypeScript, which has a lot of similar features associated with it. You can see we actually use language features in that code gen, right? Like TypeScript will complain to me if I set a wrong value here too. So we use this in our front end as part of that, builder thing that I showed you before. So we can't screw it up. There's a lot of ways we can't screw these things up that are provided by the App Platform SDK that I really, really was happy about. Schemas are great. I love schemas. I love these schemas in particular because they've made it a lot easier for my small team to be productive. So we install that schema in the storage system. Let's talk a little bit about the storage system. We don't have to run a database because of the storage system. This was the sweet thing that really sold me on this aspect of the app platform. I didn't want to run, right, we got dozens of clusters. I didn't want to run dozens of MySQL databases and monitor them. I have colleagues who have to do that for their plugins. I'm really happy that I don't have to do that, right? There's a team that maintains the app platform. If I ran Grafana now, right? If I use the current version of Grafana that's starting to get these storage features in them, I just have to monitor Grafana, right? I've already got that kind of stuff set up. So it's one less thing that my team has to run, which is really great. And the app platform APIs are really standardized. This is like what's now. Ryan and Stephanie showed you kind of what's coming. My structure is going to get a little more verbose here, but it's going to look the same for every resource type, which is really great. It's a key value store, right? You can fetch by a key that the platform generates, or you can fetch by a label expression, right? You can put arbitrary text labels on any resource, and then you can do a list by a label expression. We use this for a bunch of features in our UI. Before, if I was storing configuration for a plugin in a plugin, I would use in Grafana, I would use this thing called JSON data, right, that every plugin gets to write. They can write this JSON into the database, and they can write some encrypted JSON into the database that the backend can get safely. That's great, but if I want to write like 18 SLO objects and user preference objects and some limit object, I just have this giant JSON document that I have to fetch every time I want to look at one of those things. Or I write a MySQL database and now I have to run, or I write tables in MySQL and I have to run it. But 20 objects is not that much. It feels awful to write a SQL database to hold 20 things. So this is a really great in-between there to have hundreds of objects that I can fetch as I need and not, what I might have done before to hack that into the plugin platform. Talk about data validation. The app platform provides data validation capabilities out of the box. This is that OpenAPI v3 thing I showed before, string enums like data source and Grafana. The app platform will actually execute validation logic on every create update to make sure that it matches the spec of the OpenAPI schema. So in this case, I can't fat finger it and write Grafana. The app platform will just reject that for me. You can also write, I don't show them here, but you can write more complex validation logic across multiple fields in an expression language called CEL. It's really simple, like guaranteed to terminate, just predicate kind of language. The system will execute that for you. So I still haven't written anything that I have to run to validate my data. This is nice. We use this right now, but we also run into more complex validation. The SLO type itself has PromQL in it, right? I showed metrics before. We're going to have sums and groupings and things like that. So now I need to parse PromQL. I can't write that in CEL. It's awful, right? It's an actual language. So I need somewhere I can run the PromQL parser. And so we use those hooks that Stephanie mentioned, these admission hooks. They get called by the app platform server. I can put kind of anything I want as long as it doesn't take too long to run in there. And I get like synchronous validation. This is getting more complex. I have to deploy some code somewhere. But the really nice thing about having the API server execute all that validation logic is I don't have some proxy somewhere executing it. And I need to make sure I route all clients to that proxy, right? I can just go through the Grafana API thing. It can forward the data back to the app platform server. Everything gets run against that Terraform client. There's no like going around it, right? Somebody finds some way around that. The validation logic always gets executed. And I'm excited, I don't do this yet, but I'm excited to try running these things on a function as a service platform, right? Like AWS Lambda, because edits are bursty, right? They don't happen all the time. They might happen every time you do a git commit, every few hours, days, weeks, whatever. So it's, it would be great to be able to scale that to 0, and that's certainly something you could do in a scenario like that. So I'm interested to try that, but I haven't tried it yet. Okay, I'll talk about that watch API too that was mentioned before. So when our operator spins up, what it does is it connects to the app platform's API server, right? This is going to be part of core Grafana in the open source world. And it just issues this thing that says, I want to watch everything that matches this label expression. It does this sync process at first where it just gets everything, and then it gets notified of every update that happens as long as it's up and running. So we take that first set, we look at the real world, we see if there's any reconciliation work to do. And then we hear about every change that ever happens. Now, I have very few of these operators running. In our case, it's multi-tenant, right? Like every Grafana Cloud customer. So I've saved resources as a big Grafana operator, but even just running a single one, it's great to not have some timer that's sitting there running somewhere. Let me check all the SLOs. Is the timer retrying? Did it break? Did it, it doesn't happen. I subscribe to the thing, and the Grafana App SDK helps me make sure that that reconciliation loop is running properly. So that watch API makes it really easy for us to decouple configuration calls, right? Make me a new SLO from the downstream work. And also makes it easier for me to write more downstream work later. I don't write it it doesn't have to be in a single loop that's checking things, right? I can write as many operators as I want. They can all watch this resource. They can all do different things. I can control that, right? What are the scaling characteristics of my app? I can control what that looks like. So, for example, these are not things we do now, but these are things I've been thinking about. If I have prediction models that are trained based on SLO data, and now something configuration-wise has changed, I can notify the ML system that it needs to redo some work, right? I can, other sorts of things that I might generate asynchronously. For example, it might be nice to put references to all my SLOs into the right part of Backstage, right? I have some service definition in Backstage. People go around, look at the catalog, who owns what. It'd be great to have links to the SLOs in Backstage, right? So if I can write an operator that watches SLOs and syncs into that, that's another option. And there's no reason I have to bundle that into any particular place. I have a lot more control in terms of where I run code and what it learns. And it can watch more than just my app's resources, right? We're going to be moving more and more core pieces of Grafana onto this model. Alerting rules, dashboards, a bunch of configuration stuff is going to end up as these sorts of objects. And within some context of restricting people's access to your plugins data, right? It's not going to be a total Wild West free-for-all. You'll be able to watch core Grafana objects and respond to those changes. One thing for me, I might like to watch the Grafana summary dashboard, and if somebody deleted it, just regen it without having to, right now I still have to do that sort of pull and reconcile for those kind of resources. I won't have to do that in the future. One more shout out for the Grafana App SDK. I mentioned the code gen stuff it does. It also can scaffold a whole operator type application for you, give you some nice types. So you just provide some functions that can execute a reconciliation loop. You don't write the reconciliation loop if you use the SDK. You just write the what do I do when there's an update? What do I do when there's a delete kind of functions. So saves a lot of ceremony. You can check it out. This is open right now if you want to see what the pattern for building these kind of apps looks like. Obviously, Grafana itself doesn't implement all of these yet, but this is the SDK that my team uses. It's open source. You can go see, right? You could try to generate an operator and get a feel for what's coming from that. You can also sort of fake this by just running your own Kubernetes API server and installing resources there and pointing the app SDK to it, right? Like, that's what I do for local development, for example. I just have a Kubernetes API server running, and I put all this stuff in it. So that's how we used this prototype of Grafana's app platform to build the SLO app. Again, I could do this with a pretty small team, and a team that really actually didn't know too much about Kubernetes patterns or anything like that, and that's because the app platform took a bunch of operational burden off our hands by providing us with storage and authentication stuff. It sort of guided us towards this operator model of reacting to resource changes. It gives us some reliability characteristics we really like for decoupling work, and all this schema stuff made it pretty easy for my back-end people to talk with my front-end people, right? We share the schema, we figure out what the schema looks like together, we both get our code. I don't write a bunch of JSON, this and that kind of stuff anymore. Thanks. We have some time for Q&A. I'm excited to answer your questions.
Okay, if you have a question for Joe, let's see those hands. And this auction house rules do apply, so if you scratch your nose, you've then got to think of a question. Hello.
Hi, I'm Niklas. Company, or do you want a company, or? Yeah, I'm from Vestas Wind Systems. What's the maiden name? I actually. So for reconciliation, one challenge that people face in the Kubernetes world there is that at the beginning, when the operator starts up, you need to reconcile the entire world. I've seen Elastic, they basically have like a high priority queue and a low priority queue. Do you have, are you using something like that internally as well, or?
No, we're not. We just kind of slowly process the stuff that comes to us from the sync API. But it's just mostly, I think, not a scaling problem we've hit yet. Trying to take the don't write it until you need it sort of approach with this app. There's no reason we couldn't do something like that.
Okay. Will it become part of Grafana open source later, the SLO app, or is that?
I unfortunately don't have product roadmap announcements to be made, but obviously we built this on a closed source prototype. You know, we need those features to all be available in Grafana OSS before we did any kind of migration.
Yeah, fair.
Thank you very much. Any other questions for Joe? I'm afraid you can't ask questions if you're up in the higher tiers. Okay. Well, Joe Blubaugh, everybody.
Thanks, everyone.